In pre-calculus, we wanted to look at number 958. Rationalize the numerator of 3x plus h minus the square root of 3x over h. Now this is an Algebra 2 topic that we worked on a little bit, but definitely probably wasn't mastered by most. And it says rationalize the numerator this time. We don't have a square root in the denominator, but we do have two square roots in the numerator. So the move is, and I'll write the word, multiply by the conjugate. That's the word we want to work on. So the conjugate of a minus b is a plus b. The conjugate of the square root of 3x plus h minus the square root of 3x is the square root of 3x plus h plus the square root of 3x. In order to multiply by the top, we also have to multiply it by it in the denominator. You can't just do one or the other. And what's going to happen, without using our general box, when we multiply conjugates, like a minus b times a plus b, we've done that quite a bit. It's going to be a squared minus b squared, because that middle minus ab plus ab is going to go away. So what does that look like when we multiply square roots? If I multiply, or if I square 3x plus h, square root, I get 3x plus h. This times this. The middle part's going to go away, minus the square of the outer part. And that ends up being quite convenient. Now, we shouldn't distribute in our denominator, and you'll see why in just a second. If I simplify this numerator, 3x plus h minus 3x, we should see the 3x's go away. Then I'm just going to have an h over h times 3x plus h. And now what happens is I can divide the h's out, and my final answer will be 1 over square root of 3x plus h plus the square root of 3x. We rationalized the numerator by multiplying by the conjugate, and we ended up with this being our simplified version. This comes into play later when we start finding our limits when h goes to 0. If I look at my original equation, if h was 0, I couldn't put it in because I'd get an error dividing by the 0. But when we do this work, we can see maybe there was a hole there instead of just an asymptote.